Hello makers! Today I am going to show you how to use LED bars as police lights. Here you can see 4 LED bars. They all look the same, but they are actually very different. Each board has 8 LEDs. They can be different colors, but the most important thing is how the LEDs are connected on the board. In general, there are two common configurations, common anode and common cathode. Here's the first picture again. Now I'll show you how to connect the LED bar to an Arduino Uno. We'll be using port D. Depending on the configuration, we can connect the common pin either to +5V or to a GND pin on the Arduino board. Here you can see a common cathode setup. In this case, we turn the LED on with a logic high value. Now I'll show you how to write a program for this case. First, we have to set all used pins as outputs. Port D has 8 pins labeled as 0 to 7. We have to set each of them up. To make sure everything starts correctly, we set their initial values too low. Now we can write our program. We turn on the LEDs on pins 0, 1, 6 and 7 one by one, adding short delays between each step. Because we don't need the program to run more than once, we can use a dynamic stop instruction while true. This will repeat indefinitely and effectively stop the rest of the program from running. Our program works perfectly, but as you can see, we are repeating similar instructions way too many times. Because we use the whole port D, we can set all 8 pins in one instruction. By typing DDRD is assigned to 0B and 8 ones, we set the whole port D as output. The prefix 0B means binary notation and each one represents one pin. To set output values for this port, we can use the instruction port D is assigned to 0B and 8 zeros. Here you can see that the last 2 bits of the port D register correspond to pins 0 and 1. There is a little hidden trap for beginners. Pins 0 and 1 are used for USB communication, so it's recommended to start the program with a 2-second delay. Here is what our program does in practice. Now let's look at the common anode connection. The common anode is connected to the +5V pin. In this case, the LEDs are turned on with a logic low value. Let's change the code for this connection. DDRD remains the same because port D is still used as an output. The initial values for this connection must be changed to the opposite, high. Now we can turn the LEDs on with a logic low value. It doesn't look natural, but in reality it is the more common practice. And again, it's better to add a 2-second delay at the beginning of the program. This is the result for the common anode connection. Now we can start building and programming the poly slides. For this project, we will use the common cathode connection. First, we set up port D as an output. The initial values will be zeros. We will always turn on one red LED and one blue LED. After each blink, we will use a short delay. I found that 60 milliseconds works well. Now we turn on the second pair of LEDs. Then we add another delay and we do the same once again. We will let the code repeat 25 times. To set the number of repeats, we can use a for loop. We type a for loop, then we define a variable, in this case an integer I that is assigned to 0. The variable automatically increases after each cycle. It is defined by I equals I plus 1. The I is less than 25 is the condition for running the loop. Once I reaches 25, the loop will end. The code to be repeated must always be enclosed in curly brackets. If we didn't do that, the loop would affect only the first line under the for statement. Now let's write the second part of the code. We will turn on all red LEDs at the same time, and then all blue LEDs. A delay of 250 milliseconds between the red and blue LEDs will be fine. We will repeat this part of the code only 3 times. To do this, we will use a for statement again. That's it. Because we wrote the whole code inside the void loop function, it will repeat indefinitely. And because we use pins 0 and 1, we will again add a 2-second delay at the beginning of the program. That's all. Now we can test our program loaded onto the Arduino. Thank you for watching. If you enjoyed the video, don't forget to give it a like and subscribe to my channel.